All right, in this video, I'm picking up where we left off, and we're going to be working on some more on the rational expression problems. Okay, so I wanted to do the problem number 25, which dealt with adding fractions. So on problem number 25, we were working on adding two fractions, okay? And you got to remember when you're adding fractions that the denominators need to be the same, and they're not. So you need a least common denominator. So the least common denominator is going to be r together with the r minus 8. So we're going to try to get the denominator down here to be an r together with an r minus 8 for both of these, okay? And so what we're going to do is on this one, we had the r, we need the r minus 8. So we're going to multiply by r minus 8 to make that happen. But don't forget, if you're going to do that on the bottom, you need to do that on the top. So up here, we're going to have 7 times r minus 8. Okay. Now on the other one, we have the r minus 8 right here. What we need is the r. So that's what we need to multiply by on the top and the bottom. Okay. So once we do that, we now have a common denominator. So we can rewrite this as a single fraction. So this will be 7r minus 56 plus 9r. I went ahead and distributed the 7, if that's okay. All right, now the 7r and the 9r can be combined. So that's 16r minus 56. And then we have the r times r minus 8 in the denominator. All right, now on all of the problems in this section where you're working on an expression, you have to make sure it's simplified. But what you need to do is try to factor first, then cancel. Don't start canceling unless you get everything factored. So the 16 and the 56, there's an 8 common. So you'll factor out the 8, and you'll have 2r minus 7 left. And then you have an r times an r minus 8 in the denominator. Well, the factoring really didn't help us that much because there's nothing common that can be canceled out on the top and bottom. So you could leave it in factored form, or you could leave it all multiplied out, and either one of those would be considered finished, okay? All right, so I want to look at problem number 27. That's a problem where you're being asked to simplify, but it's a complex fraction. So it has like all these little fractions. So it has all those little fractions. And so the LCD would be 12 together with the x. So what we're going to do is we're going to multiply by 12x everywhere. Okay. This is an approach that works really well on these when you have a lot of little pieces, a lot of little fractions. Okay. So what's going to happen is we're going to simplify each of these areas, and they're going to turn into some pretty nice numbers. So this is going to be 108x. And then this x cancels out, and we have 36. And then down here, the 4 goes into the 12 3 times, and we have a 3x squared. And then here, the 12 cancels out, and we have an x. Okay? So what we did on the complex fractions, what we were able to do is clear all the little fractions by multiplying the top and the bottom by the same thing. And then I like to go ahead and distribute that 12x while I'm at it. Just saves me a step or two. Right now, at this point, it's just like on the other one. You need to factor first, then cancel if you can. So 36 is common. I can factor out a 36, and I'll have a 3x plus 1 left. In the denominator, I'm going to factor out an x, and there's a 3x plus 1 left. So that means that 3x plus 1 is a common factor I can cancel out from the top and the bottom. So I'm going to have 36 over x for my final answer. Okay. All right, and then I want to go ahead and do one more in this video. I want to solve an equation. So I thought maybe we'd look at number 29. All right, so 29 had an equation, had an equal sign. Here was the original problem. So the LCD, we're going to use it kind of like we did on the complex fraction. We're going to use it to clear the fraction. So we look at the little denominators, and we can see that x squared would be the least common denominator. So what we're going to do is we're going to multiply all the way through by the x squared. So it would get distributed, and we'd multiply both sides by it. Okay. So here's the deal. When we do that, we get x squared minus 9x minus 36, and then 0 times anything is still 0. So we just took what looked like a really complicated problem and just turned it into a quadratic equation in this case. Now, sometimes when you get to here, it'll be quadratic, sometimes it'll be linear. But you see that squared means we're going to try to factor if we can. Okay, and let's see, we can factor this into 3 times 12, minus on the 12, plus on the 3. And that works. And so then we'll set those equal to 0. And we'll solve each of these. And we get 2 equations. We get x equals -3 or x equals 12. All right, you do need to check. Neither of these, neither makes the denominator 0. So both are okay. Okay, assuming I didn't make an arithmetic mistake. But you can't divide by 0. So if you got a number that caused the denominator to be 0, you'd have to rule it out. So this one, they're both going to be your solution. All right, so that ends the chapter 6, the work on rational equations. Okay.